In this experiment, what we're going to do is we're going to react hydrochloric acid with magnesium metal in a single displacement reaction. And the goal here is to measure our stuff in a quantifiable way using proper accuracy and precision, and then try to determine what it looks like when we see magnesium metal as the limiting reactant or magnesium metal as the excess reactant. Okay? We're going to make our hydrochloric acid kind of our control here, where we're going to use the same amount of hydrochloric acid in both scenarios. So I'm going to measure out 10 milliliters of my 2.0 molar hydrochloric acid and put that into two separate test tubes. All right, so first comes the first one. Again, I'm doing my best to get really close to 10 but not overshoot that. So I got close to the line, and then I'm going to use a pipette, which is this little thing here, to put drop-wise in until I get exactly, or to my best estimate, exactly 10 milliliters of my acid. So right now I have that. So this is as close as I can get to 10.00 milliliters of 2 more hydrochloric acid. So we'll place that into our first test tube. And then we'll repeat the procedure for our second test tube. Again, pouring at first to get it close. Not going over. In fact, I did go over, so a little trick you can do is actually use a pipette in reverse and suck a little bit out, and then just put it drop-wise back in until you get it to where you want it. Again, I'm trying to be eye level here to avoid any parallaxes. And there, to the best of my abilities, I have it exactly at 10.0, so we'll remove the acid off to the side, cap that bottle for safety, and then we'll add our 10 milliliters to our second test tube here. So in theory, if I've done a good job with the accuracy of my measurements and using the same precision, to the best of my ability, I have 10 milliliters, both of 2.0 molar hydrochloric acid, into those two test tubes. So they should be the same to the best of my ability. Now, the second part of the lab, I'm going to bring in a balance. And what we want to do here is we want to measure the mass of my magnesium to the best, again, of my ability. We want to be able to see that screen for you guys. So it's kind of shadowed a little bit, so I'm going to bring that up. So the glare comes off of that. Maybe not. Yeah, I'll just use my hand to kind of hover over it when we need to. Okay. Again, putting on an empty container, we'll zero that out. And now I have my magnesium powder. And I'm going to first add in 0.10 grams of magnesium. Again, for this lab, we do need to measure. We can't just estimate. We have to measure it as best we can to that exact amount. Okay, so you may not be able to see that until I shadow it. And if you look, there it is. It's 0.10 grams of my magnesium powder. That's our first one. That will go into test tube number 1. We'll repeat that. Again, re-zeroing. And now I want 0.40, so the first, I can pour kind of fast at first here. I'm at about 0.16. I'm at about 0.25. There I'm at about 0.3. 0.35. 0.39, just need a little more. There it is. All right, so again, if we take a look at that, you can see that hopefully in the video now, that is 0.40 grams of magnesium metal. All right, move that balance out of the way. Into test tube number 1, we're gonna put the 0.1 grams. In test tube number 2, we're gonna put the 0.40 grams, okay? And to help us out with some visual cues for limiting reactant, we're going to add now bromothymol blue indicator solution. And just put a couple drops of that into each one of these. And bromothymol blue doesn't affect our chemistry at all. It just gives us a visual on the presence of acid. So we'll stir these around, and if you notice, in the presence of an acid, bromothymol blue kind of turns an orangish yellow color, is what we're seeing right here, okay? So in acidic solutions, bromothymol blue is almost a yellow, kind of an orangish, kind of peachish kind of color to it. If that solution turns basic, or we lose the acid, it will then turn blue, okay? So I'm gonna first add in my 0.10 grams of magnesium. I'm going to let that react and get as much of that in there as I possibly can to make sure we get best accuracy as possible. That looks pretty good. And we'll let that reaction run. While that's running, I'm also going to add in my 0.40 grams in test tube number 2. Again, being careful to get all of that acid, or all that magnesium, I should say, into that test tube to let that run. Now we're seeing some visual cues of chemistry here. We're obviously seeing the fizzing, the bubbling, the gas being let off. If we were running a temperature probe in these, we would be seeing them getting much, much warmer. Okay, so these are exothermic reactions that we're running here, letting them run. And we'll continue to let these run until we see no more indicators of the chemistry is continuing. So essentially we're looking for that effect that they settle down and they're no longer reacting, okay? The first one on our left-hand side, we still see that. On the right-hand side, our reaction number 2, we're still seeing kind of that white cloudiness, so that is still fizzing. What we're generating here is some hydrogen gas. So if we look at our balanced chemical equation, we're reacting magnesium plus HCl. So in that single displacement reaction, we're letting off hydrogen gas and we're producing a solution of magnesium chloride inside our solution here, okay? Now, neither of these scenarios were done at the proper stoichiometric ratio. So in both cases, we have one of them, the acid was in excess, and the other, the magnesium was in excess. Okay, be careful because I know this is going to be warm, but it's not too hot to the touch. Now if we look, this reaction has pretty much finished. We still see a little bit of bubbling here. And the reason we see that is because magnesium metal in it by itself actually will continue to react with the water itself. Okay, so the reaction won't completely stop in that case. So we're still seeing the magnesium here, but we notice a difference in color. And I'm going to amplify example, or I'm going to add to that because I'm going to add some more bromothymol blue to this to see that color difference here now. So in reaction 1, where we had 0.10 grams of magnesium, the color did not change. So we still see that yellowish peachish color, which would indicate that there's still acid present here. And if we look at the bottom, there's nothing here. We don't see any solid material left in this, okay? Which is another good visual cue that the magnesium is completely used up and gone, but we have leftover acid. In this test tube, we now see that we've turned an obvious blue color in comparison to before. That blue color is an indicator of a base being produced, okay? Which means all the acid is now gone from this. And what we're now seeing is actually what's left over is the base that's inside of here, okay? And we see at the bottom, if you look, there is still magnesium residue sitting at the bottom of our test tube. We can still see it sitting down there, that kind of gray shadow you're seeing right there, okay? And again, if magnesium did not react with water itself, we would see no reaction happening here. But because magnesium, in a warm water solution like we have now, that magnesium will continue to react with the water on its own, okay? But we know that we have no acid left because the color changed, and we still see magnesium at the bottom, okay? So those are our two different reactions we see here. In one case, we had magnesium as a limiting reactant. In the other case, we had the magnesium as a limiting reactant doing the exact same chemical reaction. Use that information, use the measurements we had here, use the precision in the measuring tools that we had to answer the questions for this lab. Thank you.